If it finds that key, it's happy, and you can't forge that. If it doesn't find that key, then we believe we've been directed to a false zone. We can also add additional keys. If we change this matching key, then we do have to coordinate with the parent, but it's a coordination problem going up instead of down. Purdue needs to notify EDU. There is no pipe coming down where an EDU change needs to notify Purdue. And you only have one parent in the tree, so if I only have notification going up, that works. I can also generate additional keys that might be used to sign the data. So now I can actually have one sort of long-lasting, extra secure key that matches the parent, and one frequently changing zone signing key that I can change on a whim without notifying anybody else. So in terms of pictures, it looks like this. What we have in the current DNS is zero security. Up here at the EDU servers, they've stored some records that say, Purdue EDU, their name servers are here. Down at Purdue, we just have the Purdue data. What I'm going to do is I'm going to add in a public key for Purdue, and I'm going to sign all the data with this public key. So I've got a bunch of signatures by that. Now I need a way to authenticate this public key. What I'm going to do is add a second public key, and I'm going to sign public key number 2 with public key number 1. Actually, in DNS, all I can do is sign RR set, so I can sign the set of all keys. So now if I knew key 1, I could authenticate any zone data. Because if I knew key 1, I can authenticate key 2. If I know key 2, I can authenticate the data. So now I just got to figure out a way to learn key 1. I take a copy of key 1, put it up at the parent, and sign it by EDU. Right? So now, instead of just getting a referral to the Purdue name servers, I get a referral to Purdue name servers, plus I get the DS record that says when you go to these name servers, you ought to find a public key that matches key 1, pub key 1, the green guy. And the reason you know this is authentic, at least it's authenticated from the point of EDU, is EDU has signed this information so the attacker can't point you to the wrong place unless the attacker had the EDU key. Now you go down to the Purdue name server, you say, give me your keys. You look for somebody that matches the green key 1. You find it, you know that's authenticated. That authenticates the blue key authenticates the data, you're done. So what did I gain by this? One nice thing I gained is if I want to change the EDU key, nobody tells Purdue. All I have to do is update this black signature up here at the top. So zero coordination if I want to change the Purdue key. The EDU key. If I want to change key 2, then I don't need to notify EDU. All I've got to do is replace key 2, re-sign the new version with key 3, and I'm done. So I can do distributed disjoint key management. This is, again, not rocket science, but now there's a little bit of operational complexity. This makes sense? So what if I want to change key 1? How do I change key 1? That one I can't do without coordination, right? Because if I pull out key 1, everything's going to break. And I claim I can do this actually by only storing one DS record at the parent at any time. And here's how we do it. We start off, so key 2 is no longer important. So let's focus just on key 1. And what I want to do is replace key 1 with the colors aren't quite as different as I would like here, but with the key 3, the purple key. All right, so I've started in this stage. Resolvers work, no problem. The first thing I do is I add my new key, my key 3, into the Purdue zone. And I haven't coordinated with anybody. I've done this solely at Purdue. And I've re-signed the set of keys with both key 1 and key 2. So if you knew key 1, you could authenticate the set and believe key 2 and key 3. If you knew key 3, you could authenticate the set and authenticate key 1 and key 2. So far, so good? Okay, now that I've got this in place, I'm free to, at a slower pace, ask my parent zone, EDU, to change the DS record. So now I have some out-of-band secure communication with my parent, which I already have because I need to occasionally change my name servers. So I'm not adding a new piece into the system. And I talk to EDU and I say, hey, I'm planning to change from key 1 to key 3. Here's my DS record. Please sign it. So Purdue adds that. So EDU adds that in, signs it with the EDU key, and I claim it still works. And I claim I don't care when that change happens. Because key 1 is still working. Well, they have the DS1 record. People go to my zone, they find the green key, they authenticate key 2 and key 3. After the change, they go to my zone, they find the purple key, they authenticate key 1 and key 2. So this change can happen seamlessly. It can roll over kind of gracefully. I can handle TTLs, I can handle timeouts, all that kind of thing. Make sense? After I wait a little while, finally for all the caches to catch up, all the signatures to expire, the old DS record for key 1 to be flushed from the system, after that's safely occurred, I can now pull out key 1, and I'm at this set that just involves key 2 and the new key 3. So I've done the change, and the only active step I had talking to the parent was sending a secure message to the parent saying, replace DS1 with DS3. And I don't care how fast you do it. I'll just check by sending a regular old DNS query and checking whether you've done it or not. So it scales nicely. It's actually deployable. This can actually be rolled out in the real DNS and is supported in fact, it's supported in bind. It's deployed in a few zones. COM has it essentially ready to run modulo some billing issues, and a few top-level zones have deployed this, especially in Europe. So in Europe, we're actually running some secure DNS zones at this point. Okay, so yeah.
Can this really solve the problem with just like in two companies? One wants to change the key immediately, the other wants to wait for a while?
So the good question here is, how quickly can you do a key change? Okay. If this is a planned key rollover, no problem, right? If I have sort of a plan to move from key 1 to key 3, I do this step. The timing isn't so important. All I need to know is that, say I want to change on November 1st to the new key. Well, sometime in late October, I add the new key in. I send the record to the parent zone, and I hope by early November they've changed the key. What if key 1's been compromised? That's your concern, right? So I need to change it immediately. I can't do that. I claim that I don't need to do that, or that actually doing that won't help. Because even if I change it immediately, the attacker who compromised the key is going to go fetch the old DS record with the old signature lifetime from the EDU key, and is going to continue replaying it. So the speed at which I can pull these things out of the actual servers is totally irrelevant. The vulnerability time period for the key depends on the lifetime of that signature at the DS record. So you're right, I can't do an immediate key chain. If a key is compromised without key revocation, which is actually a good open problem for DNSSEC, I'm basically stuck with the lifetime of the DS record.
But that can be quite a serious problem potentially.
Yes.
In the attack, right?
Especially if this is the root key, right? I mean, if this is the root key, the game is over, at least until that key expires. So key compromise. In fact, one of the things we're looking at now is how you actually do key revocation. And so this is in my view a nice MS thesis kind of problem. We've got an existing system. Now I want to do key revocation. Potentially, maybe it's more than MS thesis if it gets kind of tricky. But in theory, we should be able to revoke a key. We didn't add that into DNS. Essentially, the standard, it just didn't make it into the standard. There is an agreement on how to do it. But you're right. And there is this sort of naive thinking that still kind of permeates the standard, which says, you know what I'm going to do is I'm going to quickly pull them out of the zone. Yeah, so the focus is on, let's try to speed up the key change rule. Right? So I'm going to put time bounds on how fast the parent must respond in the event of a compromised key. And yes, for the real server, I will